All right, so we ended last time by proving that the limit of our expression went to e, right? And so now I want to look at a couple other sequences and let's see what they converge to. So let's look at b sub n, and we'll define that as n minus 1 over n. So if I want to know if this is a convergent sequence, well, I start by looking at the limit of the sequence as n goes to infinity. So we want to know what's happening all the way down the line. So we look at this limit and we try to evaluate it. Well, we can see the numerator is going to blow up to infinity. The denominator is going to blow up to infinity. So this is another good candidate for L'Hopital. So I'm just going to take the derivative of the numerator, which is 1. The derivative of the denominator is 1. So the whole limit equals 1. So we can say that b sub n converges to 1. So when we're doing problems involving sequences, and I ask you if a sequence converges or diverges, I don't just want to see the word converge or diverge, because that's a 50-50 coin flip. You could just guess and get it right. If you tell me a sequence converges, you better also tell me what value the sequence converges to and show me how you got there. And so you're going to see as we work with more and more of these sequences that there's a lot of different ways we can figure out the limits, and there's going to be different methods, but I need to know what it's converging to. If something diverges, then we simply just say it diverges. All right, so let's look at another example. So we have the sequence 5 over n squared. So if we look at the limit as n goes to infinity of 5 over n squared. Well, this is a situation where we have a constant in the numerator and infinity in the denominator. And we just saw that 5 over infinity is going to collapse down to 0. So you could write 5 over infinity and then tell me it's 0, or you can just go straight to 0. So we learned back in Calc 1, right, that 1 over n squared, that limit, when we did infinite limits, we know it goes to 0. So that's good enough for me. And you can just simply state now, well, c sub n converges to 0. All right, let's look at another one. So what we have here is a polynomial over a polynomial. Technically, this was a polynomial over a polynomial. But there's actually sort of a different approach we could take here. So we're still going to start out by looking at the infinite limit. So we absolutely are going to get some version of infinity over infinity. So we could take the derivative, and that would work, and we could keep going out. But there's another thing you can do with infinite limits. If you have a polynomial over a polynomial, we learned back in Calc 1 that only the highest powered term is going to really matter, because even if I had an n and an n squared in this expression, nothing's going to trump into the 6, right? Same thing down here. The 3 is just nominal compared to this into the 6. As this guy blows up to infinity, this thing's not even going to matter. So another way you can do this, and this is only really allowed for polynomial over polynomial expressions, is instead of taking the derivatives, well, we can say the limit is just going to equal the ratio of the highest power term in the numerator, and you want to make sure you grab the coefficient, we want the whole term, over the highest powered term in the denominator. If the power in the numerator is bigger, well, then we can clearly see this whole thing would go to infinity. If the power in the denominator is bigger, we can see that the whole thing will collapse to 0. If they're equal, well, then the end of the 6 just cancels, and this limit equals -7. So we would conclude that d to the n converges to -7. So this is actually, as far as we got in class today, this is a really good stopping point. And when we pick up tomorrow in our next class, we'll start talking about the properties of limits of sequences, and you can kind of see some more algebra tools that are in your belt. And we'll probably spend about a week on these, and then starting next week, that's when the quizzes will begin. and I'll definitely send you guys some more information about those. And then also starting next week, I'll start creating one assignment a week that's just a flashback assignment to something from units 1 and 2, because we want to make sure, you know, you'll see when we're dealing with all these sequences and series, there are no integrals really to do, and you want to make sure you're fluent in integrals because they will appear on your finals. So I will be creating one assignment a week that kind of jumps back and hits a topic from last semester, and then it's just going to be 2 to 3 problems that you can turn in, and it will be a way for you guys to generate some grades or maybe even replace some grades. But once all of your names and stuff show up in my ELC roles, then I'll be a little bit more specific about what we're going to do about your grades moving forward. So I'll see you on the next video.